Greetings and welcome to this video module on the two-factor mixed design. We will be building on this design through what we previously were looking at within the within subjects ANOVA. However, our mixed design we can also refer to a mixed design as a split plot design. And so both the mixed design and the split plot design are both the same thing, and it considers the fact that we have a design that's going to have a within subjects component, meaning that we're going to subject individuals to repeated measurements, such as after their exposure to some sort of treatment, such as professional development training, counseling strategies, instructional strategies, so on and so forth. But we're also going to be adding in now the between group variable. This between group variable could be, for example, we're going to look at demographic differences over time in terms of how they respond maybe differently to professional development, instructional strategy, or some sort of therapy. And so the demographic could be looking at differences across language groups. It could be also job title, but we could also have an independent variable in which that we manipulate, such as those who are in a treatment and control group, then to look at how they may respond similarly or differently across repeated measurements based off exposure to some within subjects intervention or treatment. As an example here, we'll just contextualize this discussion within an example that asks, for example here, do administrators and teachers have different views of the effectiveness of alternative professional development trainings? So in this case, we have actually two independent variables. The one we have the between group. The between group, actually, we're going to have three levels, and it's going to be the administrator, teacher, and the third level will be coach. The second independent variable, this is our within subjects effect that we're interested in looking at. In this case, it's going to have four levels. So we could provide professional development at the whole school level. We could do webinars where it's web-based delivery. We could do workshops within or outside of a school, or we could do the trainings within a professional learning community framework. And a professional learning community is just where you have groups of teachers, grade teachers working together to look at data and trying to use that information to guide instruction in classroom school decisions. And so in this case, we have both a between subjects independent variable. In this case, it's the position within the institution, and then we have the within subjects, and that's the professional development type. The between groups has three levels, the within groups has the four levels, and the dependent variables, the perceived effectiveness, maybe we're using an 18-item self-reported survey. So key components to any kind of mixed design are also what we refer to as the split plot. Notationally, this is identified as an A times B times S. So the A refers to the between subjects independent variable, so factor A, that's the between groups, times, and we have the B times S within the parentheses. This is because we're dealing with factor B's are within subjects independent variable times S, and the S refers to subjects. So remember, within subjects, we are exposing the same group of people to some sort of intervention or treatment. And so then in this case, we have three effects or components that we are interested in looking at. So it's derived from the A times B factorial design. And so the first one we're going to be looking at is the main effect for factor A. This is our between group component of the ANOVA that we'll be looking at. The second type is the main effect for factor B. That is across the four levels, across the professional development. Is there one type of professional development that seems to be perceived most effectively than the others? And then we also have the interaction, the A times B interaction. That is, do the administrators, coaches, and teachers, do they have different levels of perceived effectiveness of these different types of professional development type trainings? And so, within this, just like with any other type of ANOVA, is that there are certain model assumptions. And these are assumptions based off both the between and the within subjects designs. Some of the key assumptions is that each individual's observations are independent from other subjects. That is, There should be no dependency on how I will respond versus how you will respond. We assume that the observations have been generally randomly selected from the larger population. Oftentimes, this is a hard assumption to meet. Nonetheless, for this particular model, this is one of the assumptions there. And then there's a distribution for every individual within the group. So again, we're going to be collecting repeated measures off each individual, and for each individual, they're going to have their own distribution of scores across observations or across time. So within subjects, again, we have the repeated measures, and so in this case, we assume that the variances within the conditions, so with the variances within each of the 4 levels of the professional development will be the same, and then also the variances across the conditions will be the same. And so this deals with the assumption of sphericity that we must consider and empirically evaluate within subjects design. So both variances within the groups are equal across the different levels of the within subjects, but then also we have to meet that across meet that assumption of sphericity. For the between subjects, again, this is just like what we saw within the one-way ANOVA or within the factorial ANOVA, was that the homogeneity of variance, that is the variances across the whatever number of groups. In this example here, we have 3 groups, the administrators, teachers, and coaches. We assume that their scores are going to have the same level of variance across each of the conditions of the 4 professional developments. And again, with these assumptions, these are things that we can inspect by inspecting the standard deviation of the variance of the scores based off the descriptive statistics. But we can also look at these empirically by looking at like the Mockley's test or the epsilon statistic for sphericity. And then we also have the empirical test of the homogeneity of variances for the ANOVA. So some plot example here. Here would be a hypothetical data set. So here in the rows, you see we have 3 levels to factor A 1, 2, and 3. This would be, for example, the administrators, teachers, and coaches. And then we also have factor B. This is the within subject, so we have 4 levels to that. And so we had like the whole school professional development training, the webinar, the workshop model, and then we also had, for example, the professional development done within the professional learning communities. And so in this data set, we have A times B times S design with 3 levels to factor A and 4 levels to factor B. And the data has been, in this example, let's just say we have 4 individuals within each of the between group conditions here. So we had 4 administrators, 4 teachers, and 4 coaches that we collected data. And so, for example, here, the S sub 1-1, this would be subject 1 in condition 1 for the administrators. And so then for the next one down, S sub 1-2, that would be the first participant in the second level of factor A. So this would be teacher number 1, for example. And then for each of those individuals, so we have individual S's all the way down. So in this case, we have 12 rows. And then we see we have for each person, we have a score across for a score based off their, in this case, their rating of perceived effectiveness for professional developments across the 4 types. So for person number 1, they provided the professional development for the first level factor B a 13, a score of 14 for the second type, a score of 17 for the third type of training, and then a score of 20 for the last type of training. Whereas we can see the last person in this data set, person S sub 4-3, that's person number 4 in the third factor A condition, or the coaching condition, if we stick with this example, is that they gave the first type of training of a rating of an 8, for the second type of 18, for the third type of training of 27, and then for the final they gave a score of 29. So for each individual then, we have the between for factor A, And then we have 4 scores for each person based off their exposure to each of the levels of factor B. And so this would be the way in which we would expect to see the data set up in a quantitative data set, such as within Excel or within a statistical program such as SPSS. So the statistical model here, again, for any observation that we see within a data set, for example, in the previous one, we had scores of 8, 27, 29, 15, is that any one score on some variable is a function of the person themselves and their exposure to the different types of treatments or the factor that they are in. And so the key components in this Y sub I, J, K, this is individual I score based off being in condition J for factor A and then K for the type of training. And so the Y, I sub J, this is the actual score. This is the score of each person that we see in the data set. Their score of 8, their score of 10, score of 29, 27, and so on. And so within the univariate case, this is what we are focusing on within this module, within all the modules within this course, is that we have a single dependent variable that we look at one at a time, is that the model is their score is equal to mu t, so this would be the population mean, plus there's the main effect for factor A, so this is which group that they belong to on factor A, plus beta B sub J, so this would be the main effect or the condition for factor B. So again, they could belong for the main effective factor, they could belong to one of 3 types of educators: administrator, teacher, or coach. For beta, this would be a score for each of the 4 professional development types. So for what we're looking at, this equation would be applied for each person across each of the cells. Okay, so we pick out any score, one score within the data set, and this would be the statistical model. And so then plus alpha times beta, this would be the interaction effect between the person's group membership, be it administrator, a teacher, or a coach, and the level of factor B, so the type of training. So this is the interaction between someone's position in an organization and the type of professional development that they are being exposed to. This is the interaction effect between factor A and factor B. Then we have plus S I sub J. This is the person effect. This is the factor associated with that individual, and that could be a number of things. There's the general attitude, their motivation. It's the subject effect. And because, again, we have repeated measures on individuals, we also have to consider the interaction between the individual and factor B, so the different types of professional development training. And then the last component is E. That's just that random error, because, again, we're going to have a score in the data set, and we're trying the best to explain the factors that associate with that particular score. And they're going to be a function both of who they are, what populations they belong, where they stand on factor A, where they stand on factor B, the interaction between factors A and B. We're going to have also factors associated with the person themselves, as well as how that person interacts with each of the repeated measures. So how do they respond to each of the levels of factor B? And then for everything else that we can't explain, that gets kind of wrapped up into the error, that unexplained variance. Okay. This is one way in which we can approach, and that's for the analysis of variance, that's the univariate approach, and this is what we'd call like a general linear model. The other approach that we've kind of alluded to in other modules, we could look at this within a multivariate perspective because we have repeated measures on the same people. And so we have more than one dependent variable. So instead of looking at each dependent variable as its own, which we're kind of doing in the ANOVA, we could look at this within the multivariate analysis of variance, where we kind of look at the whole set of scores. In this case, we'd have 4 dependent variable scores for each of the professional development training types. We could look at this like as a single vector of scores. But again, within this, when our discussion here, we are essentially only focusing on the univariate approach, whereas a ANOVA would also be another way to look at this. We are restricting our discussion to the univariate case. And so the notation, what does this look like? How do we make judgments around looking at the main effect for factor A, or looking at the main effect for factor B, or looking at the interaction effects? And so here we kind of break this down notationally. We're looking at sums here. So again, no new information is provided here from what we've already been discussing. The only difference here is within the mixed design is that we have the between subjects components within factor A. And so the table then to our left is what we saw on the previous slide. So within each of the rows, in this case we just have we have 3 people within each of the factor A, just for save a little bit of space, is we still have our 3 levels to factor A, and we have subjects within them. In this case we have 3, the previous slides we had 4. And then factor B, the different types of professional development training are in the column. So we see B1, B2, B3, B4. Each one of those corresponds to a different type of professional development training. And then we see the Y sub 111. These are just the scores. So for example, Y sub 111 in the upper left column of the table to our left, that would be the first person in factor A level 1 administrator score within the first professional development. So person number 1 within the first level of factor A within the first level of factor B. Whereas, for example, if we just go one column over, Y sub 112, this is still the first person within the first level of factor A, first level of factor A within the second level of factor B. And you can see Y sub 113, Y sub 114, still the first person within the first level of factor A within the fourth level of factor B. And so for each of those people, then we can see that last column there labeled sum. This is where if we added up each individual score across each of the 4 conditions. So we could add up the first person's score, we could add up those 4 scores, and we get SA11, SA sub 21, SA sub 31. And this is essentially just person 1 score within factor A. So we are just wrapping up that person's score all straight across. We're not really considering factor B here. We're just saying for this person across these 4 measures, across each of the professional development training, here's their overall sum score. Okay. But then if we look at the treatment sums, okay, this is the table to the upper right. And this is what we call an AB table, because essentially we have the overall sums for factors A and B together. So again, we still see there's 3 rows, and these rows correspond to just the 3 levels of factor A. So administrators, teachers, and coaches. And then the columns B1, 2, 3, and 4 those are the 4 levels of the professional development training. And I noticed there's a typo here. So for that last column, B sub 3, that should just be B sub 4. Likewise within the cells below it there. So the capital A, B sub 11 in the upper left cell there, that is the sum of the 3 people's scores within factor A level 1 and factor B level 1. So there's 3 scores we have added up there. And so for each of the cells then within the table, that's the sum of all the scores within those combined categories. So each one of those cells is equal to the sum of the 3 or however many people within those joints. So the first one, AB sub 21, that's the sum of all the teacher scores exposed to the first type of professional development training or the whole school. what we can do is we can add down. So for each of the 4 types of professional development, if we just add up all the scores down the columns, that's the capital B. So we have B1, B2, B3, and B4. That's just adding up all the scores for within each of the different types of professional development training, irrespective if they're an administrator, coach, or a teacher. Similarly, the column labeled sum, we have A1, 2, and then it says A2 there, but it should just be A3. That is just adding up all the scores of the teachers, the administrators, and coaches, irrespective of the type of training they get. And then we see that value T in the bottom right hand side. This is just adding up everybody's score. So if we had scores collected on 50 or 150, if we added up just everybody's score, irrespective of their position being administrator, teacher, or coach, or the type of training, that would be equal to T. Okay. And the subject sums, this is what we've already identified. This is just adding up for each of all the between groups. This is just adding up all 3 group scores, all the teacher scores, all the admin, and all the coaches scores here. And so with these components, these different terms here, this is the information that we would be using to estimate the sums of squares within the ANOVA table. And so there's really no new information that has not already been addressed through previous modules. All we're doing here is just adding up certain types of scores, different types of information from be it from factor A or from the within subjects factor B. And so instead of just adding them up, we can also take means. I mean, each, it doesn't matter if we use means or sums, they're both going to give us the same information within the ANOVA table. But from those cells, we can actually estimate 3 overall means, 4 means if we also include the grand total mean. So for factor A, for any given group, all we do is just take the overall sum of their scores and divide by B, which is the number of levels of factor B. In our example, there was 4, and the number of subjects within that particular group. And so within the example we're going to do, there's going to be 4 people. So this would be 4 times 4, which would be 16. For factor B, this would be, we'd get a mean for each of the 4 professional development training types. And so this would be the B sub 1, B sub 2, B sub 3, B sub 4. Divide any one of those overall sums with any type of professional development and divide that, by A. That's the number of levels that we have within factor A. We have 3 levels within factor A. And again, we multiply that by how many people that we would have there. That would be 4. So again, 3 times 4, that would be divided by 12. And then for any of the cell means, we can get cell means. This is the average scores within, for example, what are the average scores of perceived effectiveness for administrators for the whole school professional development, or the overall average score of teachers for the PLC type training. And we divide this by n. So this is just the number of people within that cell, and we had 4 within each of the cells. And then we can also get the overall grand mean. This is just if we add up all the scores that we've collected data on. Maybe it's 12 in our example. We would divide this by the number of levels of factor A, which would be 3, multiply that by 4, because 4 is the number of levels we have for factor B, times n. This is the number of people within each of those combined groups. And so essentially what we can see here on that table there, we have average scores for A1, 2, and 3, so these are between groups, so administrators, teachers, and coaches. And then we also can get an average score for each of the different types of professional development, each for the levels of the within factors there. And then we also have then across, within the descriptive statistics table we have there, this would be the within cell means for each of the factor A levels, group 1, 2, and 3, so administrators, teachers, and coaches within each of the 4 types of professional development trainings here. So these would be the within cell means. Whereas the table there to our left, that is for our means for factor A and factor B, where our cell means are reported in the larger table to our right, which we would obtain like within the output of the statistical software, what we would use. So again, these are common descriptive statistics that we can also use besides the sums that we reported on the previous slide for estimating the analysis of variance table. And so here what this slide is providing, this is some actual data, people's actual scores within the data set. And so this is what we'd be looking at, for example, then statistical software. And essentially all we're doing here is applying the formulas to the data that we have. So we're estimating that the bracketed term A, bracketed term B for the professional development. We have the interaction between the factor A and the subjects. We have the AB, that's for the cell means. We have overall bracketed term Y. This is adding up all the square values within the whole data set. And then we have bracketed term T. This is where if we added up all the scores, we can see in the table above 900, and we square that, we multiply that, or I'm sorry, we divide that by the number of levels for factor A, which were 3, times the number of levels we had for factor B, times the number of people that we had within each cell, which were 4. Okay, so again, this is no new information here. This is all stuff that we've inspected previously. All this slide does is kind of provide us how do we estimate these bracketed terms, because these bracketed terms, as we recall, these are what we actually use within the ANOVA table. And so here we actually have the terms within the ANOVA table that we would instead commonly look at within the statistical software that we're using to make decisions around accepting or rejecting the null hypothesis. For the first term would be for the between groups. So again, the term A, that's for the between group. Are there differences between administrators, teachers, and coaches in terms of their perceived effectiveness of professional development, training? And this is irrespective of the type of training. This is just looking at the main effect for factor A. And then each of the respective columns corresponds to a different component of estimating that final F statistic. So within a mixed designs here, you can see that we're at the far right column. These are the F statistics. These are the values that we look at with the corresponding p-value to make decisions around accepting or rejecting the null hypothesis for the main effect of factor A, the main effect for factor B, and then also the interaction effect for the interaction between factor A and B. And you can see the second column is how we estimate our degrees of freedom. The formulas there are for estimating then our sum of square values, and we see the sum of squares, so we can either use the means or the sums. So for the SS, that's our sum of squares, and we saw how we estimated those bracketed terms on the previous slide. And then we have the mean square column. Again, this is the variance components that we use to estimate our F statistics. So for example, within the mean square for the between factor A, we divide that by the mean square error there. So what's the ratio of the treatment differences to the error within groups? Okay, and then we have the between subjects variance components down midway through the slide. We have factor B, and then we have the interaction between A and B here. So essentially, again, it's just applying those terms that we've estimated on the previous slide to the ANOVA table to actually estimate then the values that we would be looking at within a statistical software package, the output that we'd be making the results. And so we apply those terms that we've estimated on the previous couple slides and put them in. This just walks you through the actual application of that data estimating each of those bracketed terms to generate the ANOVA table that we actually have here. And so this would be what we'd be looking at within a statistical software package like SPSS, SAS, or R. And so what we'd be mainly looking at, as we're familiar with, is we'd be looking at our F statistics and the corresponding p-value. And so here our F statistic for the between group main effective factor A was 6.85. The star indicates that was significant at the 0.05 level, so we would accept we would reject the null. We would conclude that administrators, teachers, and coaches do hold different views towards different types of professional development. The within subjects for factor B, the different types of professional development. We see the F statistic was 127.76. That was significant at the 0.05 level. So again, there's a main effect for professional development type, so we would conclude that different types of professional development are not rated the same. However, again, we don't know which professional development or for factor A, whether teachers, administrators, or coaches had different scores. We just know that they weren't all the same. And notably here that we see that the interaction between factor A and B is significant, had an F statistic of 7.07. That was also significant at the 0.05 level. And so here, this is again where we'd want to turn our attention to more fully understand how teachers, administrators, and coaches rated the different types of professional development training, because it depended on their position within a school towards how they rated different types of professional development. So this would collectively, this would indicate we need to go and dive into some post hoc follow-up analysis to more fully understand the main effects as well as the interactions. And so what do we have here then is this is a graph illustrating the scores of group 1 in blue. So this could be administrators, green could be teachers, and the gold could be coaches. And so on the x-axis, then these are the 4 types of professional development trainings. And so for each of those 3 groups, we had their overall average scores across those conditions. So again, it's when we're thinking about interaction terms, the graphs provide us a very user-friendly way to kind of more fully understand of how group scores are across different conditions. And so once we start visualizing this, we can start asking some questions. I have a few example questions here. Is, for example, do factor A scores differ significantly at factor B level 4? This would be what we would be interested in, looking at a simple effect. So within each of the given levels of factor B, do these 3 group scores similar or different? Just visually inspecting, it looks like teachers and coaches have pretty similar scores, whereas administrator scores look significantly lower. But again, we would need to empirically test that. Likewise, we could ask, do factor A scores differ significantly at factor B level 2? So again, the scores are pretty well spread out, but are they statistically significantly different across those 3 groups of administrators, teachers, and coaches within the second type of professional development training that we were interested in looking at? Lastly, we could look at the interaction effects here. That is, are the perceived effectiveness scores of factor A groups different at specific factor B levels? And so we could look at whether or not the scores of coaches differ at factor B level 1 and 4 compared to how teachers and administrators provided their scores at the 1st and 4th level of factor B. And so this would be looking at the interaction effect there to make judgments around, for the types of trainings within factor B level 1, so this could be the whole school, versus 4 within the PLCs, are those score differences between coaches, teachers, and administrators different across those 2 levels? And that's what we'd be interested in within the interaction effect here. And this again would be some of the follow-up kind of post hoc comparisons that we would be interested in making or in pursuing if the overall f-tests were significant for the main effects and also for the interactions. And we will certainly be diving into this more. But again, the purpose of this module is to provide an overall perspective on the use of the within the mixed designs or the split plot ANOVA to guide subsequent discussions on more fully addressing these type of questions within this framework using a specific type of statistical software package. And so this concludes this video portion of this module on the mixed designs or the split plot analysis of variance.